All right, so in this video we are going to cover how to determine your horizontal asymptotes of a rational function. Horizontal asymptotes are also called end behavior asymptotes. End behavior asymptotes because they tell us what happens at the ends of the graph as x approaches positive infinity or negative infinity. So way out far in either direction, what's going on with the graph. Okay, so horizontal asymptotes. The line y equals b is a horizontal asymptote of f of x if the limit as x approaches infinity, so towards the end of the graph on the right side of f of x approaches that value b. So if the y coordinates are approaching some number b as x gets really, really big, or as x gets really, really small in the negative direction, it also approaches b, then that is a horizontal asymptote. All right, so we're going to look at a shortcut for finding these asymptotes. If you have a rational function, f of x equals g of x over h of x, and g of x and h of x are polynomials, and the degree of the numerator, g of x, is less than the degree of the denominator, h of x, there will be a horizontal asymptote of y equals 0. So anytime you have a rational function where the degree is smaller on the top than on the bottom, y equals 0 will be a horizontal asymptote. So if we look at this function here, the degree of the top is 3, the degree of the bottom of the denominator is 4, so the degree of the numerator is smaller than the degree of the denominator, so therefore we know that y equals 0 will be a horizontal asymptote for this graph. So let's look at that. I graphed this in y equals, so it looks like this graph has a couple of vertical asymptotes as well, but the horizontal asymptote is this guy that's going along the x-axis. You can see that it's approaching 0 there. My pen is not working for some reason, but hopefully you can see that as x gets really, really big or really, really negative in the negative direction, both sides of the graph are approaching the x-axis, which is where y is equal to 0. Okay, the next possibility is you might have the degree of the numerator g of x is equal to the degree of the denominator h of x. If that is the case, there is a horizontal asymptote equal to, write small here, the quotient. Remember, quotient is like division or really just a fraction, equal to the quotient of the lead coefficients of the numerator and the denominator. All right, let's look at an example that follows that. If you look at this function, the degree of the numerator is 3, the degree of the denominator is 3. So the lead coefficients is the lead coefficient in the numerator is -3, the lead coefficient in the denominator is 2. This function will have a horizontal asymptote equal to y equals -3 over 2. And by the way, all horizontal lines have the form y equals some number, and so it's always going to be y equals for horizontal asymptotes and x equals some number for vertical asymptotes. Okay, so I graphed this function. Oops. We have turn this graph off. That was the previous example. I'm going to turn this one on. You just do that by highlighting the equal sign. And we have kind of strange looking graph here, but you can see it has a vertical asymptote. It looks like at about 1.5, but the horizontal asymptote is down here at -3/2. So as x goes towards positive infinity, this graph is approaching the y values are approaching -3/2, and as you go towards the negative side, it's also approaching -3/2. So we have a horizontal asymptote equal to -3/2. And then the last case, so we went through if the degree of the numerator is smaller than the degree of the denominator, y equals 0, is a horizontal asymptote. If the degrees are equal in the numerator and denominator, you find the quotient of lead coefficients. So lead coefficient of the top over the lead coefficient of the bottom. Y equals that is the horizontal asymptote for that. And the third case, third possibility is if g of x, if the degree of g of x is greater than the degree of h of x, there are no horizontal asymptotes. You can still have an end behavior asymptote, but they won't be horizontal asymptotes. They might be a diagonal line, or it could be a quadratic that it follows. So we're not going to get into that right now. But if you look at this function, the degree of the top is 4, the degree of the denominator is 2. This has no horizontal asymptotes. Okay, and so I graphed that one as well, so let's just take a look. I need to turn this one off. Again, you just do that by highlighting the equal sign, or just hit enter when you're on the equal sign to turn it on or off. So I want this one to turn on. And when you are putting these functions into a calculator, if you want to put it in to check your work, or just to make sure your graph matches what you're expecting it to, you need to put the numerator in parentheses and the denominator in parentheses as well. So if we look at this graph, you can see on either side it is approaching, it's not approaching a single number. It looks like it's going up forever. So there are no horizontal asymptotes for that. All right, so, hang on.